this. Now let's think about what is polar coordinate system first. Now polar coordinate system is a coordinate system that actually starts from simply a pole. Why I cannot do that? From a pole, you can say this is the pole, okay? And this polar coordinate system will have two parts. We'll have the two components. We call that r theta, where the r stands for the distance from origin, and then the theta is the angle from the pole. Then suppose, for example, we have a coordinate from the polar axis. I call it a pole. Now, then suppose I have, for example, I have coordinate 3, 60 degree in polar. I usually use subscript P to emphasize that it's in pole. Now, when I use degree here, of course, you can see that's a pole, but it is a custom that we don't use degrees, we use radian instead. Now, once I write it this way, it may not be clear if it is polar coordinate or rectangular coordinate. Okay, so to emphasize that this is polar, I put a subscript P here to emphasize that that's a polar coordinate system. Now, what does it mean to say 3, pi over 3 or 3, 60 degree in polar? It means that from the pole, I will go 3 units at the angle of 60 degrees. Okay, so it's 3 units. The length is 3 units from the origin, and the angle is 60 degrees, or pi over 3. Okay, now usually this theta here we say to be the angle in standard position when it comes to rectangular coordinate system. Okay, so that's what it means. Now, by the way, I do expect that you have seen this at least in trigonometry, which is supposed to be repeated in pre-calculus. But I don't expect you to memorize too much, but at least you have seen that before, such that I can go over that pretty fast. Okay, now let's see what we have. One issue we have first is to convert from polar coordinate system to rectangular. And later on from rectangular to polar. Okay, now let's take a look first. Suppose I have that polar coordinate, rectangular coordinate system, and then let's say I have a coordinate in polar. So let's say this is the coordinate in polar. Okay, call that r theta, which means the length here is r and the angle here is theta. Now, when we try to see this from rectangular coordinate system, you will see that this guy here is the y, and this guy here is the x. Okay, now then what's the relationship between this x and y and r and theta? Now we see that x is r cosine theta and the y is equals to r sine theta. Is it okay? Now, if you think about this, this is actually the conversion from polar to rectangular. From polar to rectangular, you use this formula. Okay, so if the r and theta is known, you use formula 1 to get the x, formula 2 to find the y. Okay, now on the other hand, suppose we have x and y, how do we find the r? According to this picture here, we can apply Pythagorean theorem to get the r. So r equals to square root of x squared plus y squared. And the theta is basically a tangent inverse of y over x. Okay, now I did not use equal sign because it depends on the coordinate of that xy, where coordinate xy located. Now, let's do some problem just to give us a good feeling. Now, suppose I do example 1. Was that example 1 I have up there? Yeah, so call this example 2 then. Example 2. Let's say I pick question from number 4. Number 4, part A. We have negative 2 comma 5 pi over 4. You have to memorize this though, okay? You have to memorize that the first number refers to the radius and the second number refers to the theta, the angle, okay? Now, from our formula that we have here, however, it seems like r can only be positive, but that is actually not true, okay? That's actually not true. I prefer to say that r squared equals to x squared plus y squared, where the r may be negative. Okay, now that's a fact that I don't like. That's a fact that I don't like. Because the way we think is radius has supposed to be positive. Okay, radius is supposed to be positive in any case, but here they call that radius because it has something to do with the circles. Okay, but at the same time they say that the radius may be negative, as you can see in this example here. Now, suppose then I want to find what will be the coordinate in rectangular coordinate system. And the x will be dr for sine theta. That's negative radical 2 over 2. That's positive radical 2. And the y will be negative 2 sine 5 pi over 4. That's the same thing, huh? So x comma y is equal to radical 2 radical 2. Okay, so from this question 4a, we know at least one thing first, that the radius when it comes to polar coordinate system may be negative, even though in our other cases when we talk about radius has to be positive. Okay, but right now, just for polar coordinate system, at least we think that radius may be negative. Now, let's try to sketch this. The radius is negative 2 and the angle is 5 pi over 4. So let me do the angle first. In standard position, 5 pi over 4 is going here. Okay. Now, supposed to be in that direction, right? It's supposed to be shooting in this direction, but because the radius is negative 2, we actually shoot backward. 2 units. Okay, so this is our 5 pi over 4. Okay, now if we go in positive direction, it's supposed to be here. Let's say this is radius 2, right? Let's say this is r equals to 2. But because the radius is negative, then I go backward instead. Okay, yeah. So according to this direction, r equals to -2 is here. Okay, and according to our computation, this coordinate is radical 2 comma radical 2. Okay, now using this question, this problem also, I want you to see why we don't really like to use polar polar coordinate system. It's because of the multi-value possible. Like how to say it? It's like in rectangular coordinate system, this coordinate here can be expressed by radical 2 comma radical 2 and no other way. However, in polar coordinate system, we can express this as -2 5 pi over 4, right, in polar. But if you think about that though, let me use green instead. If you think about that, I can also use this, right? What is the length of this green color? The length is
r equals -2.
2, negative, well, 2. -2.
-2 if you shoot in this yellow direction though. If you shoot in yellow direction and r is -2, you shoot backward, right? But if I want to shoot in this direction, where the theta is what? What is the theta here?
45 to pi,
45 degrees, pi over 4, right?
pi over 4, right?
Okay. Now, if you go in pi over 4 direction, how far is it from origin?
2.
Just 2. Okay. In other words, this -2 5 pi over 4 in polar gives you exactly the same coordinate to 2 comma pi over 4. They're exactly the same coordinate. The reason we don't like polar coordinate system and you don't study that until now is because of this issue. Okay, it does take some maturity for us to be able to come back and look at this type of coordinate system again. Okay, in other words, any coordinate in polar coordinate system can be represented by more than one one representation. In fact, I can tell you more. Suppose if I want to start from this the polar axis and I go backward, what will the angle be here?
Is it -5 pi over 4?
No.
No.
Almost 2 pi, right? Only missing this part. It's -7 pi over 4. Do you see that? Now, if I go -7 pi over 4, it will give me that green highlight, the green line. Okay, so what is the radius at that time?
Still 2, isn't it?
That's still 2. That's right. Okay. Now, instead, if I want to go this way, if I want to go to this yellow line there, this will be -3 pi over 4. Is it right? Okay. But to reach that coordinate, I need radius -2.
Is the radius changing from negative to positive because it's going, it's the way the direction it's going to?
That's right. If I go backward from that direction, then I use negative radius.
Thank you.
Okay, so you see, just for this one coordinate, I have 4 different ways to present that in polar coordinate system. You see, I have 4 different ways to present it, and that's the ambiguity that, of course, we don't like to deal with at the beginning of our math career. That's why we postpone doing this much later. Okay, not to say that actually, if you think about it, we actually have only these two though, this way or that way. Okay, from here to down below here, I subtract by 2 pi. From here to down here, I subtract by 2 pi. If I add by 2 pi, subtract by 2 pi, I get the same thing. If I add pi or subtract by pi, I get the opposite radius. Imagine if I go from here to here. Do you see that? Okay, 5 pi over 4. If I subtract by pi, it gives me pi over 4. But then the radius becomes the opposite. Okay, that's for part A. Let me go ahead with part C. Part C. 2 comma negative 7 pi over 6. Okay, you do it. Find the rectangular coordinate system, and on the top of that, I would like you to also find three other polar coordinates that give you the same coordinate. Okay, give you maybe 2 minutes. Let me start. You can go on. X equals to r times cosine of negative 7 pi over 6. That's equals to 2 times negative radical 3 over 2. That's negative radical 3. While the y will be 2 sine of negative 7 pi over 6. That's 2 times 1 half. That's 1. So the coordinate xy will be negative radical 3 comma 1. That's in rectangular coordinate system.
Professor, how did the y be? How's it 1? Wouldn't it be negative 1?
Let's see. The way I see is sine negative 7 pi over 6 is negative of sine 7 pi over 6. But 7 pi over 6 is in quadrant 3. So I get another extra negative sine of the reference angle. Right? Do you see that now?
Yes, I see now. Thank you.
Okay. And then, yeah, that will be 2 times 1 half, which is equals to 1. Now, we can try to picture that, though, if you want. Let's see. The radius is 2, but the angle is negative 7 pi over 6. Negative 7 pi over 6 is quadrant 3 if you go backward. Right? So negative 7 pi over 6 is actually give us quadrant 2. And the radius here is positive 2. So we expect the angle, the coordinate to be in quadrant 2. So this is negative 3, negative radical 3, I'm sorry, negative radical 3, and this is positive 1. Okay, now another follow-up question, that the polar coordinate system, give me 3 others representation for that coordinate. Suppose, for example, if I add 2 pi, then this will be 2 comma 5 pi over 6. If I add 2 pi, right? So that's basically go 5 pi over 6 in standard position, and then going in the direction of 2. Okay, now another one is if I add pi, I get negative pi over 6. If I add pi, it's negative pi over 6, but then I need to change this becomes negative 2, which if I add 2 pi, or I add pi here, I get 11 pi over 6. Okay, now those are 3 other representation of polar coordinate. Now we have done questions from polar to rectangular, Now let's try doing from rectangular to polar. Suppose we do number 6. Number 6a, we have 3 radical 3 over 3. Now then, what will the r be? The r will be square root of 3 radical 3 squared plus 3 squared. Which is equal to square root of 3 squared times 3 plus 3 squared, which is equals to square root of 3 squared times 3 plus 1. Now, I want you to realize that I purposely not computing what is that 3 squared. And the reason is because you see that square root of 3 squared is 3. Okay. And inside I will get 3 plus 1. You see what I mean? Now, the reason well, of course, if you go on further, this is equals to 6. But the reason I show you that way of looking at that, notice that this has common factor 3. Okay, so the coordinate, quote unquote, is 3 times square root of 3 comma 1. Okay, now this is not the correct notation though. So never write this explicitly, never. Just do it in your mind. Okay, just do it in your mind. But if I need to find what is the r for this, then the r will be what the common factor they have. The common factor is 3. So r equals to 3 square root of the guy you have inside. Okay, radical 3 squared is 3, 1 squared is 1. Now, I hope you see the parallel between what happened here and what happened here. A lot faster to compute the r. Okay, so the r is equal to 6. How about the theta? The theta is equivalent to tangent inverse of y over x. Okay, now sometimes you want to use some instinct too. What is tangent inverse of y over x? That's 3 over 3 radical x. That's tangent inverse of 1 over radical 3. So what is this equal to? Pi over 6, right? Okay, now the thing is, if you use calculator and compute what is tangent inverse, you will get either quadrant 1 or quadrant negative 1. Okay, while your theta may be in quadrant 1 or 2 or 3 or 4. Okay, that's why I said earlier there, you need to adjust with the quadrant. The one here, you need to adjust the quadrant. Okay, now we see that this coordinate is in quadrant 1, and pi over 6 is already in quadrant 1. So we then can say this is equal to pi over 6. Okay. Now, what happened if I change the question? What happened if I modify the question a little bit? This time I say -2 comma -2. As you can see, it has common factor 2. Okay, so the radius equals to 2 times 1 squared plus 1 squared equals to 2 radical 2. Supposed to be -1 squared, -1 squared. I write it down so that you don't get confused. Okay, I think that one is easy to compute. You want to do it slow way, fast way, up to you. Okay, I really expect you in Calc 2, as a Calc 2 student, you can do it faster. Now, the theta, however, is equivalent to tangent inverse of -2 over -2, which is tangent inverse of 1. Now, that is pi over 4. Okay, now the thing is, we know this -2 comma -2, which quadrant it is located.
Third one?
That's on quadrant 3. So you need to find theta in quadrant 3, which reference angle is pi over 4. Pictorially, it's here, right? Pictorially, it's there. Because the reference angle is pi over 4, right? This is the reference angle. So what's the angle? The angle will be, yes, 5 pi over 4. Okay, so the coordinate here will be 2 radical 2 5 pi over 4 in polar. Or the one I have up here, that is 6 comma pi over 6 in polar. Okay, now another thing is when I factor the common factor, make sure you factor the absolute sign, because this 2, if you think about it, this 2 is actually has to be the positive, have to be positive. So you may say this way, Thomas, can I factor -2 out? Yes, you can. But if you factor -2, you need to put absolute on that -2. Okay. Now that's the variation. Let's see number 6b. Number 6b, part B, the coordinate is 1 comma -2, 1 comma -2. Then the radius will be, no common factor I have to go on, that's 1 plus -2 squared is 4. That will give me square root of 5. But how about the theta? That's tangent inverse of -2 over 1. That's tangent inverse of -2. Which, if you use calculator, it will give you answer in quadrant -1. This is tangent inverse of -2. But we know from trigonometry, tangent inverse is an odd function. You can write this as negative tangent inverse of 2. Okay, happens to be in the correct position. It's in quadrant 4 or quadrant -1. So we just call it theta equals to negative tangent inverse of 2. So the coordinate is square root of 5 negative tangent inverse of 2. Okay. Now, it happens that tangent inverse of 2 is not a nice number. So I just leave it like that. That's for conversion from rectangular to polar and polar to rectangular coordinate system. Now, the next long time, I will spend plenty of time to describe some polar curve. So I will start from the easy one. When the r is constant, theta is constant, x is constant, y is constant, and then some variation to that. And then from there we go to the second level, not that hard, but not that easy either. This type, I may even want to go over the graphing with you. And then after that, we will do some type of Limachon. Okay. And then there's another one though that I really need to go over if I have a chance. I need to go over the roses. Okay. Yeah, because we will have those kind of things later on in 10.4. So we better know how to do those. But of course, before we do the hard one, I need you to have some instinct, and that's to do the easy one. Now I will start with some simple curves. Simple curves. How to express them in polar, how to express them in rectangular, vice versa, and what it looks like. Okay, now the first one is r equals constant. For example, r equals to 3. R equals to 3. If you imagine collection of all points, this is all points whose distance from origin is equal to 3. Okay. All the coordinates whose distance from origin is 3. All coordinates whose distance from origin is 3. What do you see? You will see a circle with radius 3. Can you visualize that? If I try to graph it better, it will look like this. Okay, that's what it looks like. Now the thing is, that's what the graph look like. Can we find the equation? How to find the equation in rectangular coordinate system? Now we know that r can be expressed as square root of x squared plus y squared, right? Now square both sides, x squared plus y squared equals to 9. Now notice that that equation has the same interpretation. think I should say the same geometric to this. Okay, the same geometrical interpretation to this. So R equals constant is easy. R equals constant is easy. Now, how about if theta equals to constant? Theta equals to constant. The easy one first. Let's say when we say theta equals to pi over 6. Theta equals to pi over 6 means if I have a pole here, then theta equals to pi over 6 is all coordinate whose angle from the polar axis is pi over 6. Okay, that's all coordinates whose angle is equals to pi over 6 from polar axis. Okay. The question is, but what is the equation? What is the equation in rectangular?
Wouldn't it just be a straight line?
Well, it will be a line once it is straight, right? But specifically, that will be y equals to what x plus what, you know? Okay, we will look for that. And the way we proceed will be as the following. Now, we know tangent theta is equals to y over x, right? Okay, so that's what we know. We know that tangent theta equals to y over x. So I will apply tangent theta to both sides. Okay, we know tangent theta is y over x, and tangent pi over 6 is radical 3 over 3. So we get y equals to radical 3 over 3x. Okay, which if you look back, you notice that the slope of the line is equal to tangent theta. If you think about the interpretation, right? The interpretation is the slope of the line equals to tangent theta. And it is actually true for all line in general. So as a side note, maybe I put it here. Note the angle formed by y equals to mx plus b to positive x-axis is theta equals to tangent inverse m. Okay, now let's visualize that. Suppose I have a coordinate here, a coordinate system, and I have a line that go this way. Okay, now this is our y equals to mx plus b. Okay, now this is angle theta here. Okay, now if if the slope is m, then the ratio that we have, the rise of a run, will be equals to tangent theta. So tangent theta equals to the rise of a run. How far you go to the right, how far you go up, and how far you go over to the right. I think it's without A, huh? Sorry. Is it with A or without A?
Without.
Without rise of run. Because my run goes that way, my rise goes that way. Okay? So tangent theta is equal to rise over run, but at the same time, that's also our slope. Okay. By the way, I teach this part in my pre-calculus class though. Okay, so in my pre-calculus class, they will get this thing. I just see that none of you coming from my pre-calculus class, so I assume none of you know. I know a lot of pre-calculus teachers, they don't go this far, but you're supposed to know this in pre-calculus. Okay, now, so with this note, if somebody asks you, find the angle between these lines, between y equals to 2x minus 3 and y equals to negative 3x plus 4. Let's say somebody asks you that. Okay, then you can see the following. The slope of line 1 is 2. Now you set that to be tangent theta 1, right? Okay, and the slope of line 2 is negative 3. You set that to be tangent of theta 2. Okay, so the angle in between must be theta 1 minus theta 2. Is it right? That's the angle in between, which is equal to tangent inverse of 2 minus tangent inverse of negative 3. That's tangent inverse of 2 plus tangent inverse of 3. Now, anything after that is calculated. Okay. Now pictorially, if I try to let you imagine the question here, okay, basically this problem is not a problem you solve by graphing, okay, but we can confirm our answer by graphing. Okay, so the first line, 2x minus 3, approximately like this, right? And then the second line is negative 3x plus 4, something like this. It's supposed to be a lot steeper. So what is the angle here? What is the angle here? Okay, now notice that this is our theta 1. Okay, and this is our theta 2. Okay, so the angle that we try to find is basically theta 1 minus theta 2. Okay, which they end up adding. Adding each other because they go opposite direction. Okay, so this question is supposed to be an easy question, but it relies heavily on this knowledge, though. It relies heavily on this knowledge. Okay, now that's for this theta. Theta equals to constant. Now let me change the question to be a bit harder. What happens if what happens if I make theta instead is equal to 2? Not a nice number. Then what does it look like? First of all, let's say this is the polar axis. The angle will be 2 radian, not 2 degrees, 2 radian. Two radian is more than pi over 2, but less than pi. That's why we know that 2 is in quadrant 2. Okay. So all the coordinates that whose angle from the positive x-axis is 2 radian. How do we proceed? We do it the same way. Tangent theta equals to tangent 2, y over x equals to tangent 2. So y equals to tangent 2 times x. Okay. Now, if you use calculator, then you will get a decimal for this, but you can just leave it like that actually. Okay. Furthermore, what happens if I have x equals constant? A vertical line. What if x is constant? Let's say, for example, x equals to -3. You know what the picture looks like. X equals to -3. Like this, right? Okay. Now we know what the graph looks like, but how do we write that in polar coordinate system? Now we know that x is r cosine theta. Okay. Now it is a tradition. It is a tradition to write a polar equation as r as a function of theta. Okay, in other words, we isolate the r and have the theta on the other side. R equals to -3 secant theta. Okay, so I replace x by r cosine theta, and so for r, actually we can go further. What happens if we have y equals to constant? Let's say, for example, y equals to +2. Let's say y equals to +2. Then I replace the y by r sine theta. Okay, and then try to solve for r. Okay. Now, what happens if we go a bit further? Let's say if I have 2x minus 3y equals to 7, let's say. I just picked random numbers. And how to write this in polar? How to write this in polar? We will write it this way. Okay, I will rewrite the x as r cosine theta. Okay, and the y as r sine theta. And then I factor the r. So r is equals to 7 over 2 cosine theta minus 3 sine theta. Okay, now actually we can go on a bit further from there. Okay, but I prefer to show you something else that you don't expect. But it has a lot to do with interpretation though. Okay, let's try to sketch this graph here. 2x minus 3y equals to 7. It looks like this approximately. Okay, that's what it looks like. Are you with me?
Yep.
Okay, now I try to relate the question, the polar equation that we have here to a question that you don't realize you could have answered when you learn this in Pythagoras. What question? The question of distance of this line from origin. What is this here? Okay, what's the distance between this line from the origin? Okay, and the answer is this distance, the shortest distance here, is actually equals to 7 divided by square root of 2 squared plus 3 squared. Okay. Now that's because if we look back to this function, if we look back to that r equal to 7 over 2 cosine theta minus 3 sine theta, if you look back, r is minimum, okay, which is the minimum distance, right? Because there are a lot of distances though. There are a lot of distances. This is also a distance, but you can tell this distance is longer than the shortest distance in red color, right? The one in red color here is the shortest distance, and that's what we define as the distance from origin to the line, okay? Even though this is distance from origin to one point of the line, that's not the shortest possible, okay? That's not the shortest possible. Now, r is minimum when 2 cosine theta minus 3 sine theta is maximum. Okay, basically, it reached the maximum when you have the amplitude, right? But what is the amplitude? The amplitude is equal to square root of 2 squared plus 3 squared. That's the amplitude. Okay, so r is minimum when you divide 7 by the amplitude. That's the distance. In fact, In fact, if you know some transformation that you're supposed to learn in trigonometry, this is the angle in which you turn the line. No, it's not really visible, huh? That's because I don't make it big enough. Well, anyway, you can actually rewrite this as r equals to 7 over square root of 13 cosine theta plus some angle, okay, and that angle here is the angle here, okay. But for you to learn that one, you need to pay more, okay. You need to take another class, trigonometry. I'm not teaching that here, okay. It's just like all of a sudden, once we rewrite it into a polar equation, we can actually use that equation to find the distance from origin to that line by you just using this formula. Okay, now let's go on a bit further. Let's go on a bit further. I know I kind of like choke you with all these new polar equations here because my assumption is you have seen this before. You just need to remind yourself about this, and you have a chance to watch the lecture video again to remind yourself. If you don't really get it right now, look at your notes and then look at the lecture video again. Oh, by the way, I post the lecture video of today's lecture at the discussion. See, let's say we go to the discussion today. Last time, let's go to the discussion last time. On Monday. Okay, I post the lecture video. It takes me like around 1 or 2 hours to download it and to upload it to YouTube though. So you can assume that after our lecture today, you can assume that tomorrow the lecture video should be on your discussion board already. I post it on YouTube and then I give you the link on the discussion board. Okay, yeah. So if you want to kind of like chew it again. Now let's go back to our notes. The second type of polar curve that we need to learn are r equals to a cosine theta. Let's say, for example, r equals to let's say 6 cosine theta. Now, before we actually do this, we need to do this. I need you to have some feeling first. By first constructing a table, okay, for theta and r. So when theta equals to 0, what's the r? When theta equals to pi over 6, pi over 4, pi over 3, pi over 2, and so on and so forth. Okay, just the special angles. You don't need to be too precise, just the special angles. This will be, what's that? 2 pi over 3, and then 3 pi over 4, 5 pi over 6, and pi, 7 pi over 6, and then 5 pi 4, 4 pi over 3, 3 pi over 2, and so on and so forth. Okay, up to 2 pi. You know what? Instead of asking you to do it, how about me doing it faster? Let me see if I have the technology here. I should have the technology, I just don't know where to find it. Okay, I do expect that if you are a Calculus 2 students, you know how to use Excel. Do you have Excel on your computer? Well, if you do, then you can just do it this way. So this is my theta, and this will be my R, which is, what's that, 6 cosine theta? Okay, now then for my theta, I will start from 0, and then I will add, just make it multiple of 15 degrees. 15 degrees. I don't know, this computer will use. Now I want to use this is equal to cosine of that angle. But I'm not sure if this is in. Give me a second. I wonder if it is in radian or in degrees. No, that's in radian. So I need this to be pi over 12. Oh, okay. So equals to pi open close parentheses divided by 12. Keep it at 15 degrees. This is the one I changed into radian. By pi divided by 180. Easy, let me make it into only 2 decimal places. Well, anyway, this is our value. Okay, are you following me so far?
those would be the R values. We still have to multiply them by 6, right?
Yes,
Okay.
Oh yeah, you're right. So I forgot to multiply by 6. 6 times. Okay. Huh? Oh. This is not right. What am I doing? I had my pi earlier here. Times pi divided by 180. No wonder the number looks so wrong. Okay, this looks a lot better. Okay, my original intention is I would like you to do this. My original intention is I would like you to use your calculator and then find all the values, right? Now, instead of doing it one by one, it will be nice if you as a Calculus 2 students able to use your Excel and do this, okay? Now, in your test later on, if you want to use Excel, go ahead. If you don't, you want to do it by hand, fine. But if you know how to use Excel, it will be a lot faster. Now, why I want you to do that? Because I want to graph it. Suppose I want to graph it. Suppose I want to graph it. Now then, let's pick this. I need to graph it, but at the same time, I cannot graph it here. So let me snip that. Back to my notes. Boom. If it's not too big, I make it big. Okay, I hope that's better now. Okay, so save us some time, right? Instead of asking you to do it and then I'm sitting down doing nothing. I did it for you. Okay. Yeah, if you know how to use Excel, then it will be much better. If not, then too bad. Okay, but I will plot this 0 degrees, 0 degrees, that's 6. 1, 2, 3, 4, 5, 6. Okay, and then 15 degree, 5.8. I make it in a way that this is 90 degree. Okay, this is 90 degree divided by 6. So each spoke here is actually 15 degrees off. Okay, so for 15 degrees, that's 5.8. Oops. And 30 degrees, that's 5.2. 45 degree is 4.24 approximately here. And then 60 degree is exactly 3. At 60 degrees, exactly 3. 75 degree is 1.55. And then 90 degree is 0. I'm sorry, 75 degrees should be here. It should be here.
We still see the Excel screen.
Sorry. Oh yeah, that's right. So I plot them now. I just plot them. 0 degree is here. 15 degrees, 5.8 is here. 30 degrees, 5.2 is here. This is 1, 2, 3, 4, 5, 6. So 45 degrees, that 4.24. 60 degrees is exactly 3, so 3 units, and I turn 60 degrees. 75 degrees is 1.5. Approximate here, and then 90 degrees is 0. So if I trace that, it looks approximately like this. Okay. Now the thing is, what happened once we go into quadrant 2? Because in quadrant 2, 105 degrees, this is 105 degrees. I need to shoot back. It's negative. So I shoot backward 1.55. So 105 degrees, but I shoot back negative 1.55 approximately here. Okay, 120 degrees in this direction, 120 degrees in that direction, but the radius is negative 3. You see that? Okay, which means I need to shoot backward 3 units. For 135 degrees, or 135 degrees, I need to shoot back, how far? Negative 4.24. So for this direction here, 1, 2, 3, 4.25. 1, 2, 3, 4.25 approximately. Negative 150 degrees, negative 5.2, negative 165 degree, negative 5.8. So again, because it's in quadrant 2, I'm supposed to shoot in this direction. Okay, but because the value of the radius is negative, then I shoot backward. Okay, now let me connect these points. That's what I get. Okay, now when you go on, for example, 195 degree, 195 degrees supposed to be this direction here, right? But the radius is negative 5.8, negative 5.8. I hit this same thing. When I go backward, I hit that one. So you notice that for this 6 cosine theta, r equals to 6 cosine theta, it gives us a circle, okay, and it forms a circle only in pi radian, or 180 degrees. You already form a circle. If I run from 0 to 2 pi, I actually go over the same circle twice. Okay. Now, as you can see, this circle is actually a circle with radius 3. Circle with radius 3 and centered at 3, 0. It's a circle with radius 3, centered at 3, 0. Okay, that's a circle with radius 3, centered at 3, 0. Now the question is, however, though, how can you come up with that, Thomas, from the equation? It seems like the way you did it, from the equation you graph it, and because we are lucky, we can see that it is a circle. And because we are so lucky that we can see the radius and the center, and therefore we can find the equation. But is there any systematic way for us to find the radius and the center without graphing? And that's the reason I go over this question. We'll do it this way. We start with r equals to 6 cosine theta, right? Okay. Now, I know r squared equals to x squared plus y squared. But at the same time, I also know that r cosine theta equals to what? Equals to x.
X.
Okay, so what I will do is I will multiply both sides by r. Multiply both sides by r. This will give me r squared. That simplifies to x squared plus y squared later on. And the right hand side, I get 6r cosine theta, which will give me the x. Now then, I move the 6x to this side and complete the square. I will add what? I will add 9 to both
9.
sides, right? So then I will get x minus 3 squared plus y squared equals to 3 squared. Now, that's the equation of the circle centered at 3, 0 with radius 3. Okay? Now, I'm about to give you a break. But during this break, I would like you to also do, it will take you nearly forever if you are slow though. I would like you to do r equals to, let's say we have 8 sine theta. Okay, let me just ask you to find the equation in rectangular system. Okay, that should take you only 3 minutes. And I hope once you find the equation in rectangular system, you know what the graph look like. Okay, together with the break, let's come back at 6:05. Okay, I multiply both sides by r. I get x squared plus y squared equals to 8y. Move it to the left hand side. And then what do I need to add?
$16.
We add 16. That will give us x squared plus y minus 4 squared equals to 4 squared. So that's a circle centered at 0,4 and radius is 4. Okay, now I want you to notice something at this point. The following, very important note to help us simplify our computation. If r depends on cosine theta only. Now, you know, r is a function of theta. It always depends on theta. But if you have only cosine theta there, then the graph is symmetric with respect to quote unquote x-axis. Now, let's see. If we look back to our this r equals to 6 cosine theta, notice that the graph is symmetric with respect to x-axis. Do you see that? Right? And also, if we go even further, notice that r equals to -3 secant theta, which is basically r equals to -3 over cosine theta. So it depends on cosine theta, right? The graph is this one. It's symmetric with respect to the x-axis. Is it okay? Now, on the other hand, if r depends on sine theta, then the graph, I should say then the graph is symmetric with respect to y-axis. As what you can see on our graphing paper. We have earlier r equals to 8 sine theta. Is symmetric with respect to the y-axis. Do you see that? Okay. We also have r equals to, what's that? 2 over sine theta. Remember that? That's also symmetric with respect to the y-axis, right? So if r as a polar function depends only on sine theta, then it is symmetric with respect to the y-axis. If it depends only on on cosine theta, it will be symmetric with respect to x-axis. Okay, those are two things nice to know. And what else I want to say earlier? I suddenly forgot. Oh, this thing. Let's look back. This is 8 sine theta. 8 sine theta, what is the radius?
4.
4. Where's the center?
0.
0, 4.
0,4. Now, we can say this way. The center is 4 from origin on the y-axis because it's sine. Okay, the radius is 4. The center also 4 units on the positive y-axis. Okay, on the positive y-axis because it's sine. Now, if I change this becomes cosine, the radius will be
Still 4.
the radius will still be 4, okay, which is actually half of this A, half of that A. You are with me on my graphing software, right?
Yeah.
Okay, so the radius of the circle resulted is half of that A, and it will be on, the center will be on the x-axis if it is cosine, it will be on the y-axis if that's sine. So let's say if I rewrite it instead of 8, I make it negative 8. Now, what will the radius be?
4.
The radius will still be 4, but where's the center now?
At negative 4.
To be more precise, negative 4, comma 0. That's right. Okay. If I use, let's say, negative 5 sine, negative 5 sine theta, negative 5 sine theta, then this will have radius
2.5.
with center
At 0, negative 2.5.
C at center 0, comma, negative 2.5, negative 5 over 2. Okay. Now, if I change this instead of sine, I make it negative 5 secant theta. What will that be? That will be a line. That will be a line with x equals to negative 5. Okay. So what I need you to memorize, is this before I go hard. What I need you to memorize is this. Memorize. Okay. R equals to A cosine theta is a circle with radius A over 2 and center at A over 2, comma 0. I think I should say the radius is absolute of A over 2. Okay. Now, while R equals to A sine theta will be a circle with radius same A over 2, but the center will be 0, comma A over 2. Now, if I have R equals to A secant theta, this will be a line x equals to A. And R equals to A cosecant theta, that will be a line y equals to A. Okay, memorize this though. Memorize this. Now, the last part that I want to go on, I don't think that's the last part, but the harder part, I should say, is how to deal with Limachon. How to deal with Limachon. What is Limachon? Limachon has this pattern, R equals to A plus B sine theta, or R equals to A plus B cosine theta. Okay, basically constant plus or minus some scalar multiple, some coefficient of sine theta or cosine theta. Okay, our textbook only give one example. Okay, I think I will do more examples, but I will use my software to speed it up. Okay, I will use my software to speed it up. Now, let's use our intuition first. Let's use our intuition first. Now, because the first style here depends on sine only, then this will be symmetric with respect to what?
Y.
With respect to
Y-axis.
Y-axis, that's right. And because the one here depends on cosine theta only, then this will be symmetric with respect to x-axis. Okay, now because it is symmetric with respect to x-axis, so you imagine what happened on the top here will be copy-paste what happened at the bottom there, right? So what we will do later on, we will do just angle 0 to pi, and then copy-paste that below. You see what I mean? Does it make sense with our plan?
Yeah.
Okay, while if it is symmetric with respect to the y-axis, then I will, it will be whatever the graph on the right-hand side, that's the graph you have on the left-hand side, right? So our plan will be, we will do, find the graph from quadrant -1 to quadrant 1, and copy-paste that, flip that to quadrant 2 and quadrant 3. Okay, that's our plan. That's our plan. Now, suppose for example, I have the following question. Suppose for example, I have the following question. R equals to, let's say, 2 plus 3 cosine theta. Okay, 2 plus 3 cosine theta, and from here we see this is symmetric with respect to x-axis. Okay, so we will graph. If I need to graph this and to save my time, we'll graph for theta from 0 to pi only, then flip to get the graph below, the other side. Is it okay?
Yeah.
Now, originally, when we do the graphing, I would like you to do the following. When theta equals to 0, and then 15 degree, 30 degree, and so on and so forth. We do it faster now. Instead of 0, 15, 30, we will do 0, 90 degree, 180 degree only. Okay. I will show you the more refined graph later on, but we just need to get the feeling. Now, when theta equals to 0, what is R?
5.
5. Okay. And when theta equals to 90?
2.
2. Okay. Now, this 5 is actually coming from 2 plus 3. Notice that cosine is maximum when theta is 0, right? And cosine reach 0 when the theta is 90 degree. So you just get the constant, while when theta is 180 degrees, we will get -1, and that comes from 2 minus 3. Okay, so our rough sketch for now will be, when it is 100, when it is 0 degree, I go 5 units out. At 90 degrees, I go 2 units up, and at 180 degrees, it will be -1. Okay. So we expect the graph later on kind of like go this way. Kind of go this way. It kind of look that way. And then when we copy paste and flip that, we will get the other side. Okay, now notice we have a loop here. You will see that we have a loop here We have a loop because the coefficient of the cosine or later on sine, you will see, is greater than the constant. So there's a possibility the radius becomes negative. Okay.
Can you go over how to plot the points one more time?
Later on. Loop because a small loop. Because R can be negative for some here. Okay, now let's see if I want to plot that. If we want to plot that, I need to copy this first. Okay, now you help me then. When theta equals to 0, it's 5. Okay, when theta is 90 degrees is 2. When theta is 180 degrees is negative 1. Now, if you want to refine it, then find what will R be when theta equals to 30 degrees. R equals
2 plus 3 radical 3.
Repeat again.
Oh no. 2 plus 3 radical 3 over 2.
What will that be? Use your calculator.
It's around 4.6.
4.6. Okay. Oh, sorry, it should be here. Now then, what happens if theta is 120 degrees? I think that's 0.5. I think that's 0.5. So if you see how we trace it, it actually goes this way. I still don't get used to it. It goes this way. At some theta, it will reach 0. At some theta, it will reach 0. And go back. Let's see, what is when theta is 150 degrees? Negative 0.6. See here? Then if we go on further, we flip whatever the graph we have there, we get this thing. Okay. Again, we have loop. We have some loop. We have loop here. We call that a smaller loop or internal loop. Well, because there's a possibility that the radius is negative. If the constants are the same, like the 2 and 3 instead is both, let's say 3. Let's say another example, r equals to 3 plus 3 sine theta. We know this will be symmetric with respect to y-axis. Okay, so our theta, when we do our theta later on, we'll do from negative 90 degrees to positive 90 degrees. Okay, that's the plan. Okay, now if I want to roughly sketch that, when theta is negative 90 degrees, the r will be 0. When theta is 0 degrees, that will be 3. When theta is 90 degrees, is 6. Zero, 3, 6. Okay, now I propose that it will look like this. It will look like this. And then later on, we will copy paste that on the flip side. That's what it looks like. Okay, now if you want to make it more refined, have 0 and then 3 and then 6. But that's for theta equals to negative 90 degrees and then 0 and then 90 degrees. Now let's fill in the gap when theta equals to 30 degrees. That will be 4.5. When theta equals to 60 degrees, 5.4. 5.6. Okay, so negative 30 degrees, that will be 1.5. Negative 60 degrees, that will be 0.4. So at negative 60 degree, 0.4. Negative 30 degree is 1.5. 0 degree is 3. 30 degree is 4.5. 60 degree is 5.6. So it looks like this. That's what it looks like. And you use the coordinates that you had earlier. You kind of refract that to the left. 5.6, 4.5, 3, -1.5, -0.4. That's the reflection. Supposed to be. Approximately, that's what it looks like. Okay, if you want to refine that further, then you make it into 15 degrees. But for us, we just need to kind of like imagine what the graph look like once you see the equation. Okay, now let's take a look on what if we graph them so that we can see it faster. Okay, so 3 plus 3 sine theta. We know this will be symmetric with respect to the y-axis. Okay, that's what it looks like. Because the constant and the coefficient are exactly the same, then they possibly zero. The radius possibly zero at some theta, and therefore it touched the origin. Okay, now if I change that 3 becomes 2 for the constant, notice that the radius may be negative. That's what it looks like. Okay, the radius may be negative because 3 cosine negative is minimum at -3. 2 minus 3 is -1. So we may have a loop. Now what happens if I turn it around? 3 plus 2 cosine theta instead. What is the maximum R? What's the maximum R?
Is it 5?
Okay, how about the minimum?
-1?
No, I don't think so.
No. Oh, wait.
Just 1?
Just 1, because cosine negative 2 cosine theta will be minimum at -2, right? So 3 minus 2, the minimum is 1. Now, because the radius can never be 0, then you will see that this limation will not touch the origin. And still symmetric with respect to x-axis though. Okay, now in this case, it doesn't have loop. It doesn't even touch origin. Okay, now let's try to do it this way. We compare this graph here next to each other. What happens if I make it like this? So the maximum value will still be the same. The maximum value will still be 5. You see? Okay. The maximum still be 5, and the y-intercept will be the constant. So for the purple one, the y-intercept is 3. For the red one, the y-intercept is 2.5, right? Okay, and then the minimum value for the top one is 1. So it seems like it's intersecting at -1, but if you see that from the point of view of polar, the radius from origin to that is 1 at the angle of 180 degrees. Okay, now together with what happened if I have another equation, 2 plus 3 cosine theta. Okay, so you see that, let me take this picture and then put it down in our note. You see that the blue one is r equals to 2 plus 3 cosine theta. It has a loop because the coefficient is larger than the constant. Okay, now the red one, it doesn't have loop, but it touched the origin, right? The radius is, the maximum is 5, so it must be 2.5 plus 2.5. And because it is symmetric with respect to the y-axis, the x-axis, it must be cosine. Now, the purple one, I hope this is purple. No, it's not dark enough, huh? Do I have purple one? I have this one. Okay. So r equals to 3 plus 2 cosine theta. Okay. Now it doesn't have loop, and the minimum distance from the origin is 1. So the difference between these two numbers must be 1, and the sum must be 5. Okay? Now, I will skip the leaves until next time. I want to go on with the derivative stuff. Derivative. dy dx, for which we get the slope of the tangent line, is later on done by using the chain rule dy d theta over dx d theta. Okay, now don't forget that x equals to r cosine theta and y equals to r sine theta. Therefore, let's do this first. What is dx d theta and dy d theta? In some sense, if possible, please memorize this. Don't forget the r is actually a function of theta. So I will need to do product rule. Okay, I need to do product rule. That is equal to dr d theta cosine theta plus r times d cosine theta d theta. Is it okay? Which will be dr d theta cosine theta plus r sine theta with negative. Let me change that plus becomes minus. Let me ask you to do the dy d theta. Try. I'll give you 1 minute maybe. This is the derivative of r sine theta over d theta. That will be dr d theta sine theta plus r times the derivative of sine theta respect to theta. That will be dr d theta sine theta plus r cosine theta. The way we derive this is basically the way we did the dy dt and dx dt. We just changed the parameter. Instead of t, now the parameter is theta. Okay, now if possible, memorize that. Okay, I don't think you need to memorize the following, but if you do, that's fine. Okay, so this is dr d theta sine theta plus r cosine theta. Dr d theta cosine theta minus r sine theta. Now, we will have horizontal tangent line. We have horizontal tangent line if dy d theta equals to 0, but the denominator dx d theta is not. Okay, vertical tangent line if dx d theta equals to 0, but dy d theta is not. Okay, now you will see later on we have the issue if dy d theta equals to dx d theta equals to 0. If the numerator and denominator equals to 0, then use limit. Okay. In turn, you may need to use L'Hopital rule. Okay. Now let's do some problem. Let's do some problem. I have only 10 minutes, so I can only do one problem. Let's say I do, oops, sorry, in case you still need to write that down. Let's say, for example, we do let r equals to 2 plus 2 sine theta. Okay, notice that this r is a function of theta. Okay, so the question is find the coordinate in polar. So basically the polar coordinate where the tangent line is horizontal, A horizontal, B vertical. Okay, Now let's see. Let's do x first. X will be r cosine theta, right? Okay, so dx d theta will be dr d theta cosine theta plus r, actually minus r sine theta. So if I plot this derivative of r respect to theta, I will get 2 cosine theta. Which will give me 2 cosine squared theta minus 2 sine squared theta minus 2. Set this equals to 0. I get 2 cosine 2 theta minus 2 equals to 0. So cosine 2 theta equals to 1. Cosine is 1 at 0. So 0 plus n pi. So theta equals to n over 2 pi. I'm sorry, I'm missing something. Oh, so terrible. See, I forgot to distribute this thing here. My bad. I forgot to distribute this thing. That's quite terrible. Yeah, that's very terrible. Okay, I have to erase everything. So let me rewrite it first. See, I tried to do it fast and I haven't. Now, I will get the vertical tangent line if I set this equal to 0. How to do this? Let me change this to sine. Okay, so this will be 2 minus 2 sine squared theta. Get negative 4 sine squared theta minus 2 sine theta plus 2 equals 0 divided by negative 2 and then factor I get sine theta equals to 1/2 and then sine theta equals to 1. So theta equals to pi over 2 for sine theta equals to 1. For 1/2, theta will be pi over 6 and pi over 6.
For the sine theta plus 1, wouldn't you want -1?
Oh, -1, that's right.
The quantity sine theta plus 1.
It should be negative here, so this is
It'd be
3 pi.
3 pi. Yeah. Awesome.
Okay, now, but we are not done yet though. We are not done yet. If we get vertical tangent line, It may happen at this angle, and this angle, but we still need to compare that with the dy d theta later on. Let me do dy d theta. Y equals to r sine theta. So dy d theta equals to dr d theta sine theta cosine theta. Derivative of phi r with respect to theta is cosine theta. This is my problem. So this will be 2 cosine theta sine theta plus 2 plus 2 sine cos theta, which is equals to 4 cosine theta sine theta plus 2 cosine theta. Set this equal to 0, divide by 2. Maybe I say I factor 2 cosine theta out. I get 2 sine theta plus 1 equals 0. So either cosine theta equals to 0 or sine theta equals to negative. Now, cosine theta equals to 0 when theta is pi over 2 and pi over 2. Sine theta is negative 1/2 when seven pi over 6, 11 pi over 6, quadrant 3 and quadrant 4. So let's put them together. Okay, let's put them together. Dx d theta equals to 0 at x equals to pi over 6, 5 pi over 6, 3 pi over 2. Dy d theta equals to 0 at theta equals to, sorry, I wrote it wrong. Theta equals to pi over 2, 3 pi over 2, 7 pi over 6, 11 pi over 6. Do you see any common angle?
3 pi over 2.
3 pi over 2.
3 pi over 2, okay. So this requires us to analyze further later on, okay. For this, we need to analyze further later on. But at least we can say from here already that we have horizontal tangent line at theta equals to pi over 2, 7 pi over 6, 11 pi over 6, and vertical tangent line at theta equals to pi over 6, 5 pi over 6. Okay. At theta equals to 3 pi over 2 unknown. Because both of them give 0 such that the quotient is undefined. What we will do then is we will approach that slowly using limit. So dy dx at theta equals to 3 pi over 2 later on, we will use limit. Theta approaching 3 pi over 2 of the expression dy d theta. What is the expression dy d theta? 4 cosine theta sine theta plus cosine theta. That's on the top. At the bottom, we get at the bottom. 2 cosine squared theta, 2 cosine squared theta minus 2 sine theta minus 2 sine squared theta. Okay. Now then from here what we need to do is actually try to analyze that. What happened. You may need to go even slower. You may need to do limit theta going to 3 pi over 2 from negative side and limit theta to 3 pi over 2 from positive side. Okay. Let me try to go on a bit further here. I can reduce by 2 and factor the cosine here. Factor 2, so I get 2 sine theta plus 1. How about at the bottom? I can factor the 2. And then what else? Cheat here. And take the 2 out, I get negative 2 sine squared. Negative 2 sine squared theta plus sine theta minus 1. Wonder if I can go further. Get cosine theta 2 sine, and at the bottom I get 2 sine theta minus 1 and sine theta plus 1. Isn't it? Yeah, the 2 cancels, and I have a negative arm. Let me put the negative arm here. Now then, how do you do this from here? You may want to separate them. Okay, you may want to separate them and apply L'Hopital rule. Give me a bit more time. Okay, I will take this one, the 2 sine plus 1 over 2 cosine theta minus 1. And then limit theta goes to 3 half over 2 cosine theta over sine. The thing is, when I plug in 3 pi over 2, the 1 here, it gives us a nice number. I think that will be actually becomes positive later on. Okay, while on the right hand side here, when I plug in, I get 0 over 0. Then I apply L'Hopital rule. Okay, when I apply L'Hopital rule, it's still not good. Then I do the plus minus thingy, and you will see that's plus minus infinity, which means the slope is infinity at that point. Okay, so theta equals to 3 pi over 2, we get vertical tangent line instead. Okay, I have to stop here. But at least I need you to be able to do the following suggested homework from 10-3, number 1 to number 25, and then 29 to number 45. Actually, I need to choose them. I don't want you to do too much that it's not related. I bet. 1, 3, 5, 7, 9, 11, 17, 23, 25, 29, 30, 30. No, not number 29. And then number 55, 57, and 59. 61 and 63. It seems to be a lot, but should be okay. Okay, that's for today.
Thank you, Professor. Take care.